Welcome back to the next stats video. This one's on a topic called correlation, and specifically, how do we interpret correlation if we're given it on a graph? Let's see what that means. When we talk about correlation in statistics, we're talking about the strength of the relationship between two different variables. In this course, those variables are always x and y. When we see correlation on a graph, what we're talking about is a scatter plot graph, which is a bunch of different dots on a Cartesian plane that represent pairs of data from a distribution. Now, the scatter plot shows points of data that kind of form a trend on a Cartesian plane. You can kind of see that they're trending upwards or downwards, or they're all close together, or they're kind of far apart. And that's what I mean by trend. Here's a couple of examples where you should be able to see a trend in the points on the scatter plot. Now, this trend is a kind of a representation of the x and y pairs that were gathered from a distribution. Now, correlation can exist between any two variables, but on a scatter plot, what we're looking for, if it's the strongest possible correlation, those points form really close to a perfectly straight line. Now, the weaker the correlation, the more spread out the points are on the Cartesian plane. Notice in the examples that I just put up, it doesn't matter if the points form a positive sloping trend or a negative sloping trend. I don't care if those points are going up the graph or down the graph. All I care about is how close they are together, regardless of if that's a positive slope or a negative slope. So the closer together, the stronger the correlation. The further apart those dots are, the more spread out they are, the weaker the correlation is. Now, on a final exam question about correlation on a graph, they'd probably give you 3 or 4 graphs and ask you to rank them either from strongest to weakest or weakest to strongest based on the graphical representation of the correlation. So all you'd be looking for in that case is how close those points are together. That's your strongest, and how spread out they are, that's your weakest. Now, here's a couple of examples of how that might look on an exam.